Okay, now we're going to continue with the elimination method. That previous video was 25 minutes long, which is really getting to the point that it's hard to get them to upload. So we will go ahead and continue this. Now, let's look at another one. We have x minus 4y is equal to 2, and 4x minus 16y is equal to 8. Okay? Now, notice that I have a 4 here, and up here, if I multiply by a negative 4, they'll be opposites of each other. So we're going to multiply this entire equation by a negative 4, which is going to give me negative 4x plus 16y is equal to negative 8. And now this one is 4x minus 16y is equal to 8. Well, what's going to happen here? When I add these equations, I get 0 plus 0 is equal to 0. So this is 0 equal to 0. So what does that tell me? That is a true statement. Since 0 equals 0, what that tells me is one equation was a multiple of the other equation. They're the same line, and therefore this has infinitely many solutions. Because that entire line is the solution. So let's look at another one. X plus 3y is equal to 0, and 4x plus 2y is equal to 3. Now notice, what do we have here? On this one, we don't have either one the same, nor do we have one that I can just multiply 1 and get to the same. It doesn't matter whether you look at your y or your x. Your lowest common multiple between a 3 and a 4 is a 12, and the lowest common multiple between a 3 and a 2 is a 6. So I'm going to raise these to a 6 or a negative 6, okay? So what will I do to get there? Well, I am going to take and multiply this equation by a negative 2, and this one by a 3, because negative 2 times 3 is a negative 6y, and 3 times 2 is a positive 6y. So my y's are the one that I'm going to eliminate. So let's do that multiplication. Negative 2 times 3 is a negative 6x, plus, minus 6x equals 0. And then this one, I have 12x plus, how about fixing that and putting a y? Thank you for letting me know. And a 6y here is equal to 3 times 3 is 9. So you see you have to multiply each one of these numbers by that 3. Now when I add these equations, negative 6x plus 12x is 6x. Negative 6y plus 6y is 0. And so it's equal to 0 plus 9 is 9. Now divide by 6, and my x is equal to 3 halves. All right? So, as you see on this one, I don't have a nice integer. I now have a fraction. So now I'm going to take this and put it back either into this one or this one, and I think I'm going to choose this one. So 4 times 3 halves plus 2y is equal to 3. Well, 2 goes into 4 2 times, and I end up with 2 times 3 is 6 over 1, or 6, plus 2y is equal to 3. Subtract my 6 from both sides. I end up with 2y is equal to 3, negative 3, divide by 2. And I have y is equal to a negative 3 halves. So my ordered pair for this one is 3 halves, negative 3 halves. Okay, so here we ended up with fractions. Not as nice, but you can still work with it. And again, you can check them, okay? So now let's look at one more problem of these. Okay, 5x minus 5y equals 3, and x minus y equals 12. Okay, we could do this one by substitution if we wanted to, but I'm going to do it by elimination. Since I have a positive here, I'm going to multiply this one by a negative 5, so that when I add them, it eliminates it nicely. So here we have, I'm going to write it over, 5x minus 5y equal to 3. And this is negative 5x plus 5y is equal to, negative 5 times 12 is a negative 72. No, 60. Negative 60. Okay? Got to decide what my multiplication is, okay? Now, when I add these, what happens? 5x minus 5x is 0. Negative 5y plus 5y is also 0. And this is equal to a negative 57. 0 equals negative 57. This is a false statement. Remember, whenever you end up with a false statement, what does that tell you about your solution? It always, always, always tells you that if this is the case, there is no solution. So that is an important thing to remember. If you end up in a false statement, you have no solution to this particular system of equations. All right? And that is the end of that lesson. It was a pretty long one. All right?